In this video, we're going to look at three techniques for sketching functions. The first of these techniques is to do with the symmetry of the function. Now, there are two types of symmetry that a function might have. The first of these is a mirror symmetry, and a function with a mirror or reflection symmetry is said to be an even function. An even function is defined by the property that f of x equals f of minus x. Examples of even functions include functions like x squared, or x to the power of 4, or any even power of x. And here are two examples of even functions. Firstly, the function 1 over 1 plus x squared, which looks like this, and secondly, the function cos x. Even functions have this reflection symmetry, so if we reflect the picture from left to right, the picture looks exactly the same in mirror image. The second type of symmetry that a function might have is a rotation symmetry, and a function with a rotation symmetry is said to be an odd function. So odd functions have the property that f of x equals minus f of minus x, and odd functions include odd powers of x, such as the functions x and the function x cubed. So odd functions have a rotation symmetry, and here are two examples of odd functions, the function firstly x cubed here, and secondly the function sine x. So each of these functions have a rotation symmetry, so if we rotate the graph through 180 degrees, the picture looks exactly the same. So each of these functions, if we rotate it, the function looks exactly the same as before. Now, a second useful technique for sketching curves is to look at small values of x and large values of x. And in many cases, we will find that the function simplifies and becomes easier to plot when either x is very small or x is very large. So as an example of this, let's consider the function f of x equals 1 minus x squared divided by 1 plus x squared. First of all, we notice that this function only involves even powers of x, and therefore it's an example of an even function. Now, when x is very small, the x squared term here is small compared with the 1 here, and therefore f of x is approximately equal to 1. When x is very large, then the x squared term here is much larger than the 1 here, and therefore f of x is approximately equal to minus x squared over x squared, which is just minus 1. So for large x, f of x is approximately minus 1. So putting together these bits of information, we can now sketch the function. So it looks like 1 for small x and minus 1 for large x, and it goes through 0 when x equals 1. So this function looks something like this, and then because it's an even function, we can reflect it to draw the other half, and the other half looks something like that. The third useful technique for sketching graphs is differentiation. So if we work out the derivative of the function, f dash of x, or df by dx, that tells us the slope of the function, and so whether the function is increasing or decreasing. So as an example of this, let's consider the function f of x equals x cubed minus x. So this function only involves odd powers of x, so it's an example of an odd function, and its derivative is f dash of x equals 3x squared minus 1. So using this information, this tells us that when x is very small, the derivative of the function is minus 1, so the function is decreasing, and when x gets very large, f dash of x is positive, so the function is increasing. So using this information, we can sketch the function and use the fact that the derivative is negative for small x. The derivative becomes 0 when x is 1 over root 3, and then for x greater than 1 over root 3, the function becomes positive, something like this, and tends to infinity as x goes to infinity. Then finally, we use the fact that the function is odd to sketch the function for negative values of x, and we complete the picture something like that. So in summary, we've looked at three useful techniques for sketching curves. Firstly, looking at whether the function is even or odd. Secondly, looking at small values of x and large values of x. And thirdly, looking at the derivative of the function.